Alright, hi guys. So those of you who are missing class today, I just want to make sure that y'all are caught up so you are not super totally lost tomorrow. Today we are starting a unit on electricity and magnetism. And historically, students have struggled a lot with this concept because it's not just that, you know, north and south poles attract and north poles repel. It's a lot more complicated. It goes into the science of why things are magnetic and why electricity works, like the actual physics and forces of the whole thing. So I'm going to walk you through what we did in class, so hopefully you won't be that super lost tomorrow. So we started off by doing a couple of little experiments. I had kids go around to different stations to experiment with magnets and static electricity to see how exactly they work. So I'll demonstrate those real quick. So these are magnets. These are paper clips right here on my table. I had kids move the magnet towards the paper clip slowly to see if they would attract without actually touching. As you can see here, they do attract without touching. You have to get pretty close still because these are kind of weak old magnets, but they do not have to touch for them to attract. I then had kids put the paper clips in water to see if the paper clips would still attract to the magnet outside of the cup. And as you can see, they do. It doesn't matter if it's in water or out of water. And then if you put the magnet in the water itself, you see that they still attract without touching inside the water as well. So the medium itself does not matter. Magnets and paper clips will still attract without touching if it's in air, water, whatever, vice versa. And then I also had kids do a quick thing with static electricity. So I had them charge a balloon by rubbing it on their hair or their clothes. This one's already charged. And then I had them hold it over a plate of pepper. And what you see happening is that the pepper attracts to the balloon. Again, without touching, the pepper sticks to the balloon after it has been charged. So, essentially what we determined is that both static and magnetic forces act on objects without touching each other. If y'all remember the test we just took, we've already discussed a force that works on things without touching, and that is gravity. And similar to gravity, the farther away things are, the less force there is, or the less attraction there is, but there is still a force there. Just like how you have invisible gravitational fields affecting objects all throughout the universe, you also have invisible magnetic fields and electric fields affecting objects all throughout the universe, even though you cannot see them. So, to get into the science of why that happens, we first have to understand what atoms are, right? So, I know y'all have learned about atoms in the past. You have, this is a really crappy Sharpie, you have protons in the center, which are positive, and then you have neutrons in the center also, which have a neutral charge. And then orbiting around the atom, you have electrons, which are negatively charged. This is a really crappy drawing, but you get the point. This is a proton, a neutron, again, neutral charge. Protons are positive, and then you have the negative electrons orbiting around the atom. Now, of these three things, only the electrons can move from atom to atom. The neutrons and the protons stay stuck in place in the center because they are in the nucleus, but electrons are free to go whenever and wherever they please. That's important for later. So, when, say, you zoomed in to all of the electrons and the atoms in this box of tissues, okay? This box of tissues is obviously not magnetic. It's made of paper or cardboard, which is not magnetic. And if I were to zoom in to that paper, I'm going to draw a bunch of circles to represent the atoms. If I were to zoom in and I could see all the electrons orbiting around their atoms, all of them would be orbiting in totally random directions like this, okay? Some are doing this, some are doing this, some are doing this, okay? They're all totally random. But if you were to look at the same thing in a magnet, all of the atoms would be orbiting in the exact same direction. This is why magnets are magnetic and why other things like paper, plastic, wood are not magnetic. It all has to do with how the atoms are orbiting around, or excuse me, how the electrons are orbiting around their atoms. If something is magnetic, they are all orbiting in the same direction. If something is not magnetic, they are all orbiting in random directions. Now, that brings us to how the actual fields themselves work. So, let's say I have a magnet, and I have a north pole and a south pole. Because all magnets have a north and a south pole, you can't have just one by itself. And again, all the atoms are revolving in the same direction. what if you could see the invisible force lines, they would come out of the North Pole, circle around, and they would go back into the South Pole on both sides, just like this. Okay, North Poles always push, South Poles always pull. That's why when you have two north ends of a magnet, you cannot, I mean, depending on how weak the magnet is, you can, but you feel the resistance when you try to put two North Poles together. That is because they're both pushing. Okay, you can't put two pushes together. And same thing with South Poles. You can put it around, try to push them together, you'll feel resistance. You cannot put two South Poles together because they are both pulling. The reason North and South Poles attract each other and always go together is because the forces always go out of one and into the other one. They attract each other. Now, with electricity, if you have a positive charge and a negative charge, the exact same situation happens. The positive charge is always going to push. So again, if you could draw the invisible force lines, they would look something like this. The positive charges are always pushing, the negative charges are always pulling. Okay, that's upside down. Exact same situation for both. So if you have two positive charges and you try to smush them together, they would repel the same way that two North Poles of a magnet would repel. If you have two negative charges, they would repel in the same way that two South Poles of a magnet would repel. But because you have a positive and negative, they attract each other. That's why electrons orbit the nucleus anyway, because the nucleus has protons, which are positive, and they attract the electrons. Now, going back to the balloon, when you rub the balloon on your head, what happens is you are transferring electrons from your hair onto the balloon. Remember, only electrons can move. Protons and neutrons always stay in the same place. They can't move. Electrons can move. You're moving electrons from your hair to the balloon, which gives the balloon a negative charge because it has a ton of electrons on it. Now, if the balloon attracts the pepper, that means that the pepper has a positive charge, and positive, negative attract, just like how north and south attract. So that is basically where we left off today. I hope that makes sense. Email me if you have any questions.